Example 12.9. In figure 12.12, you will see that R1 is equal to 10 ohm, R2 is equal to 40 ohm, and R3, which is 30 ohm, and same way R4. Okay, here you can see that this is our circuit. Okay, in which we can see that R1 and R2 are attached with a parallel connection. Which connection? Parallel connection. Same way R3, R4 and R5, okay, three of them are connected with the parallel connection. But if you see that R1 and R2, okay, and R3, R4 and R4, okay, they are connected with the series. Okay, here in this structure you can see that in circuit you can see that R1 and R2, both of them are parallel to each other. Okay, same way R3, R4 and R5, okay, these three of them are parallel to each other. Okay, so same way here you can see that 12-volt battery is connected to the arrangement. Calculate the total resistance in the circuit. Okay, in this circuit we have to find total resistance as well as total current flowing in the circuit. Okay, how much amount of current is passing or conducting by this, okay, that we have to find. Okay, suppose we replace the parallel resistance R1 and R2 by an equivalent resistance of resistance R dash. Okay, if we see that R1 and R2 are connected with the parallel, then equivalent resistance, let it be R prime. Okay, we have taken R prime as a equivalent resistance of R1 and R2. Okay, so here you can see that our formula will be R dash is equal to 1 upon R1 plus 1 upon R2. Okay, so in this, if you replace it in place of R dash, okay, we have to find out. So there will be as it is. So R dash or R prime will be as it is, but in place of R1, if we substitute, then our R1 is 1 upon 10. Okay, R1 is what? Okay, 10. So it will be 1 upon R1. So it will be 1 upon 10 plus 1 upon 4040. Okay, so if we simplify, then at that time we will get 5 upon 4040. Okay, on simplifying we will get R dash is equal to 8 ohm, because R1 and R2 are connected with the parallel. If we find a parallel connected R1 and R2 equivalent resistance, then it will be R dash. Okay, we have assumed that R dash or R prime. Okay, so it will be R prime. R prime is equal to 8 ohm. Same way, if we talk about the resistance 3, R3, R4 and R5, okay, three of them are connected with the parallel. So it will be 1 upon 30, 1 upon 20 and 1 upon 60, because R3 is 3030, R4 is 2020 and R5 is 6060. Okay, so if we simplify R double prime, okay, which is our equivalent resistance of a R3, R4 and R5. So it will be what? So it will be 10 ohm. Okay, so R prime we get 8 ohm and R double prime which we get 10 ohm. Okay, so if we talk about that, okay, that R1 and R prime and R double prime, okay, they both of them are connected by series connection. Here you can see at this point, okay, and at this point, okay, both of them are connected with the series. So R dash or R prime plus R double prime, it will be 18 ohm. So we have get total resistance in a circuit. If we want to find a current, then we have a Ohm's formula, which V is equal to IR. So if we take a subject of formula I, we have taken I as a subject of formula. So I is equal to V upon R. okay, and we have already given that V is equal to 12 volt upon 18 ohm, which we have find resistance, so it will be 0.67 ampere. Okay. We have seen that in a series circuit the current is constant throughout the electric circuit. Thus, it is obvious practical to connect an electric bulb and electric heater in the series, because they need current of widely different value of operate properly. Okay. Another major disadvantages of a series circuit is that when one component fails, the circuit is broken and none of the component work. If you have used fairy light, okay, fairy light means what? Okay, on Diwali time, okay, we are using what? Okay, fairy light. Okay. વોટ તો કે આપણે રોશની જે કરીએ છીએ, ઓકે, ઓકે, સિરીઝ આપણે ગોઠવીએ, સિરીઝ વિચ વી સે ઇટ એઝ અ સિરીઝ, ઓકે, દેટ ઇઝ નોન એઝ ફેરી રાઈટ. ઓકે, એમાં જોઈએ છે જો એક બી શું હશે, તૂટી જશે. ઓકે, ઇફ વન ઓફ ધ bulb get break or a connection get broken down, then it will not pass throughout the series. Okay, so that will not give a proper amount of fairy light. Okay, fairy light जो यो proper amount में work करेगी नहीं. Okay, so fairy light will not work properly. Okay, so in this you can see that series connection have some of the disadvantages, in which you can see that if the in a series connection, if the particular resistor or particular bulb get broken, then it will not conduct electricity, or it will the charge will not pass to the last resistance. Okay, so here you can see that there is a disadvantage of series circuit. Okay, one component fail, then the whole circuit will be broken or cannot be used further. Decorate building on festival, okay, marriage celebration, etc. You might have seen the electrician spending a lot of time trouble locating and replacing the dead bulb. Each has to test to find which has fused or gone. Okay, for that what electrician has to work a lot. Okay, they will check a dead bulb, okay, and which of them has fuse. Okay, they have to find out, so the electricity can pass to a whole connection, okay, and whole fairy right. On the other hand, a parallel circuit divides the current through the electrical gadget. Okay, if we talk about the parallel circuit, then what will be there? It will divide electrical gadgets. Okay, current will be divided on through the electrical gadget. The total resistance in a parallel circuit is decreased. Okay, due to which you can see that total resistance, okay, in a parallel circuit will decrease, and this is helpful particularly when each gadget has different resistance. Okay, when each of them have different resistance, at that time also this is very helpful and require a different current to operate properly. Okay? So they will need different current for that. Now the heating effect of electric circuit. When we know that a battery or a cell is source of electrical energy, the chemical reaction within the cell generate the potential difference. Okay, if we talk about the chemical reaction, due to chemical reaction also in a cell, we can see that potential difference can be generated. Okay, if we talk a cell, okay, in a cell we can see that potential difference should be there. Okay, this or that potential difference is due to the chemical reaction which are carried out in that cell. Okay, cell के अंदर क्या तो chemical reaction. Okay, chemical reaction is carried out, due to which you can see that potential difference can be generated at a two terminal. Okay, two different terminal. Okay, that set the electron in motion to flow the current, and due to which they will set a electron, okay, to move. Okay, and if the electron will move from one place to another, current will be flown on that particular resistor or a system of a resistor connected to the battery. Okay, the resistor whichever get connected with the particular battery, okay, if the resistor, okay, resistor is connected to the battery, from the battery what will be that, that electron will flow in that resistor, and due to which current will flow on that resistor. Okay, we have also seen that the maintain the current, the source has to keep expanding its energy. Okay, source should need a energy. Where does this energy go? A part of the source energy maintaining the current may be consumed into useful work. Okay, like a rotating the blade of an electric fan. Okay, this energy, okay, get what? Okay, that energy get what? Okay, for the particular phenomena, mechanical form, okay, in which you can see that rotating the blade will be there, okay, of electric fan. Okay, then rest of the source energy may be expended in the heat. Okay, we have seen that because of the flowing of a current, energy will be formed, but where this energy is used. Okay, so first we have studied that that energy is work for the mechanical purpose, okay, in which you can see that rotation of a blade, okay, rotation of a blade, due to which you can see that fan get on and we will get a proper amount of air. Okay, so for that purpose, but rest of the energy, okay, rest of the energy are converted into heat energy. Which energy? Heat energy. Okay, during the fan, okay, fan whenever we on the fan, at that time we can see that fan get exothermic energy. Okay, due to which whenever we are touch the particular fan, at that time we will feel that a fan get hot. Okay, temperature, raise the temperature of a gadget, and due to which you can see that gadgets temperature get increased. We often observe this in our everyday life. Okay, for example, an electric fan become warm if used continuously for a long time. Okay, if we are using a electric fan for a long period of time, then what will be seen? That fan get warm. Okay, वो क्या हो जाएगा? तो कि गर्म हो जाएगा. On the other hand, if the electric circuit is purely resistive, okay, same way if we talk about the another form, then if the electric circuit is purely resistive, that is configured of a resistor only connected to the battery. Okay, with the battery only it get connected. The source energy continually get dissipated entirely in the form of heat, and due to which you can see that heat is generated, okay, in a large amount, and this is known as heating effect of a electric current. Okay, and the heat is generated, that heat or that phenomena is known as heating effect of a electric current. Okay, because of the flowing of a current in the entire resistor or resistance. Okay, due to which the heat energy is generated. That heat energy, okay, is generated due to which phenomena? Okay, heating effect of a electric current. Okay, electric current has flown from the gadget or a resistor, and due to which resistors get heat energy, and whole the phenomena is known as heating effect of the electric current. This effect is utilized in devices such as electric heater, electric iron, etc. Okay, in electric iron as well as electric heater, okay, we can see that this effect is utilized. Okay, so here you can see that electric heater. Okay, in electric heater also we can see that heat energy is produced. Same way if you talk about the electric room heater, okay, which are very useful for warming a room. Okay, same way electric iron, okay, which we are doing, okay, for our close purpose. Same way electric kettles, okay, that is also useful for maintaining a temperature of a tea, coffee or etc. Consider a current I, okay, flowing through the resistor R, where the potential difference across it be V. Okay, we have taken current as a I, resistance as a R, and potential difference as a V, okay, which we know it very well. Let the T be the time during which the charge group flow across. Okay, what we have taken? T as a time, R as a resistance, current as a I, and potential difference as a V. Okay, and Q as a charge, electric charge of a current. The work done by the moving the charge through the potential difference V is VQ. Okay, if we talk about the work done, okay, how much work done? Okay, so we have to find then work done will be multiplication of a or a product of a charge and potential difference. Okay, so that will be the product of a charge and potential difference, that will be VQ. Therefore the source must supply energy equal to VQ in time t. Okay, so source is supplying how much energy? Okay, VQ. Okay, VQ amount of energy is supplied, okay, by the source. Okay, so hence the power. Okay, if we talk about the power which we have indicating by capital P, input the circuit by the source is P is equal to what? Okay, VQ upon T. Okay, we have a power P is equal to VQ upon T. Okay, so it will be power is equal to what? Okay, VQ upon T. Okay, once again I am repeating, we have a work done is equal to VQ, okay, which will be the product of a electric charge and potential difference V. Okay, so our work done will be VQ. So if we talk about the power, okay, power will be what? Okay, work done upon time taken. We know it very well. But here our work done is VQ. So VQ upon T. Okay. Now we know it very well. Q upon T. Okay. We know it very well. P upon I is equal to Q upon T. Okay. In the starting of the chapter we have studied. Okay. What electric current is the electric charge upon time taken. So if we replace it VI, okay, we will get VI. So from this we get P is equal to VI. Or the energy supplied to the circuit by the source in the time t is PT. Okay, how much energy is supplied? Okay, it will be PT. Okay, so we know it very well. We have got P as a what? We have got energy as a PT. Okay, so heat energy will be VI into T. So it will be VI upon T. Okay, so P into T we will get is as a P, which we have already known that P is equal to VI. So H is equal to VI T. Okay, so thus the steady current will flow how much amount of energy? Okay, VIT. Okay, now applying the Ohm's law. Okay, if we apply in this Ohm's law, okay, if we apply Ohm's law, then we will get I square RT. Okay, now how this I square RT is formed? Okay, so here we know it very well. H is equal to what? Okay, H is equal to VIT. Okay, in that VIT, okay, we know it very well. V is equal to what? Okay, V is equal to IR. Okay, we know it. V is equal to IR, which is our Ohm's law. Okay, so in place of V, we can able to substitute IR. Okay, so IR into I into T. Okay, so I and I, it will be I square RT. So we will get H is equal to I square RT. Once again I am repeating. Okay, we have a formula H is equal to VIT. So we have which formula? H is equal to VIT. Okay, in VIT, if we replace V is equal to IR, we have replaced V is equal to IR. Okay, so IR. Okay, I will be as it is, T will be as it is. So it will be I square R T. Okay. So we have got this formula H is equal to I square RT. This known as a Joule's law of heating. Okay, which we said as a Joule's law of heating. Okay. The law implies that a heat produced in the resistor is directly proportional, which indicates that heat which is produced is directly proportional to the square of a current. Okay. So what is the relation between heat and current? Okay. So it will be H is directly proportional to I square. Okay. So this is the relation between them. Same way, directly proportional to the resistance for the given current. Same way, you can see that H is directly proportional to R. Okay. And same way, the next is directly proportional to the time for which the current flow. Okay. And it is also directly proportional to the time. Okay. So you can see. In practical situation, when an electric appliance is connected to the known voltage source, it is used after the calculating the current through it using the relation V is equal to IR or I is equal to V upon R, which is our Ohm's law. We find it very well. Okay. So, if we talk about this, the steady current is a purely resistive electric circuit. Okay. Here you can see that the resistance is connected, current is flowing, same way voltmeter is connected. Okay, same way here battery is there and ammeter is there. Okay, if we talk about that, electric iron consume energy of rate 840 volt. Okay, so we have a formula P is equal to V upon I. If we take I as a current, okay, subject of formula I is equal to P upon V. Now the heating effect of a maximum will be I is equal to what? Power which is already given. Okay, and we have a formula. In place of P we have taken written 840. We have substituted 840 upon 220, which is our voltage. Okay, so we have got 3.82. Okay, current. In same way, what? Okay, we have a formula of Ohm's law through which we have find resistance. Okay, when we talk about the minimum rate, okay, minimum rate, at minimum rate there is the watt of 360. Okay, so same procedure will be same. Okay, in place of 840 we have replaced this 360 because it is for minimum, and we have taken 1.64, and once again our Ohm's law we are applying in this, and we will get 134.15 ohm. Same way, the next is 100 joule of heat is produced each second. Okay, so heat is 100 joule, resistance which is 4 ohm, and time which is 1 second. Okay, which is 1 second. Okay, which is given. Okay, what will be its potential difference? So we have to find V. Okay, we have a formula H is equal to I square R T. Okay, which formula we have? H is equal to I square R T. In that we have taken I square as subject of equation. So it will be H upon R T. Okay. Now if we remove a square, then it will be square root in right hand side. So it will be square root of H upon R T, which is already given. Now substituting all the value which we are getting from the question, okay, which we have already 100 joule, R is 4 ohm, and same way T is 1 second. Okay, so it will be 5 ampere. Okay, and same way from the Ohm's law we will get volt. Practical application of a heating effect of electric current. The generation of a heat in a conductor is a inevitable consequence of the electric current. In many cases it is undesirably as it converted useful electric energy into heat. Okay, useful electrical energy is converted to a heat, due to which there will be a lack of electric current. In electric circuit, the unavoidable heating can increase the temperature of component and alter their proportion. However, heating effect of electric current has many useful applications. Okay, there is a lot of advantages as well as disadvantages of heating effect. The electric laundry iron, electric toaster, electric oven, electric kettle, and electric heater are some of the familiar devices based on Joule's heating. Okay, all of them are the devices which are based on the Joule's heating, in which we can see that useful heat energy is produced. But what about the rest of them? The electric heating is also used for the produce light. For the light purpose also we are using electric bulb. Here the filament must be retained as much as heat energy as it possible. Okay, filament should retain a proper amount of heat energy, then and only it is applicable and possible to generate it, so that it get very hot and emit light, and due to which filament will get hot and it will emit light, and it must not melt at such high temperature, and temperature should be limited, okay, so it can maintain its melting capacity. A strong matter with the high melting point such as tungsten, okay, strong matter, the matter should be strong and it should have a high melting point. Okay, for example, if we talk about the tungsten, okay, which is used for the making the bulb filament, okay, which are very useful for preparing a bulb filament. So bulb filament is made with the tungsten. Filament should be thermally isolated as much as possible using insulating support, etc. The bulb are usually filled with the chemical inactive nitrogen and argon gas to prolong the life of filament. Okay, so in bulb we can see that which gases are present, nitrogen as well as argon gases are present, okay, which are very inactive. Chemically it is inactive and it will extend a life of a filament. Okay, it will extend a life of a filament, and due to which it will work for a long time filament. Okay, so the work of nitrogen and argon is to prolong or increase the life of a filament. Most of the power consumed by the filament appear as a heat, but small part of it in the form of light radiation. Another common application of a Joule's heating Joule's heating is for the fuse, which we use for the electric circuit. In electric circuit, we are using a fuse, okay, which are very important. It protects the circuit and appliances by stopping the flow of unduly high electric current. Okay, whenever high electric current is flowing in the appliances or in a circuit, it will stop that high electric current, and due to which the appliances will not damage. Okay. The fuse, which is placed in the series with the device, it consists of a piece of wire and made of a metal or alloy approximately melting point, for example aluminum, copper, iron, lead, etc. If the current larger than specific value flow through the circuit, the temperature of the fuse wire increases. This melt the fuse wire and break the circuit, and due to which the circuit will be broken. Okay, whenever the temperature of a fuse will increase, okay, due to which it will melt the fuse wire. Fuse wire will be melt and break the circuit automatically. The fuse wire is usually encased in the cartridge of a porcelain and similar material with the metal end. The fuse used for the domestic purpose are rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, etc. Okay, depending on the fuse capacity. For an electric iron which consume 1 kilowatt electric power when operated 220 volt. Whenever it is operating 220 volt, it will conduct how much consume? That 1 kilowatt will be consumed. Okay? So that is 4.54 ampere will be flown in the circuit. How much current is flown? Okay, 4.54 ampere will be flown. In case 5 ampere fuse must be used. So 5 ampere will be used. Now if we talk about electric power, the electric power which we have already studied, P is equal to V I. Okay. So V I is P is equal to what? Okay, P is equal to V I, in which V is equal to P is equal to I square R. Okay, I square R, and it will be V square upon R. How? Okay, in place of I, we have written V upon R. In place of R, P is equal to I square R, and where I is equal to, okay, we know it, V is equal to I R. If we prepare subject of equation, I as a subject of equation, I will be V upon R. So if we apply V square upon R square into R, so one R will be cut and we will get V square upon R. So the SI unit of electric power will be 1 watt. Okay. So the unit watt is very small. Therefore, actually practice we use of a much larger unit, which we said as a kilowatt. So we use kilowatt. Okay. So 1 kilowatt is equal to 1 kilowatt. Okay. Kilowatt means what? Okay, 1000 watt. Okay. And if we convert 1 hour into second, then it will be 3600. So it will be 3600 into 1000. Okay, so it will be 3.6 into 10 raised to 5. How? Okay, 20. Okay, these are the 20 and these 30. Okay, so total will be 50, and 36 is converted into decimal 3.6. So it will be 3.6 into 10 raised to 6 watts per second. Okay, now 10 raised to 6 watt second, which we said as a 3.6 into 10 raised to 6 joule. So here we have given volt as well as current. Okay, so VI, which we get as a 110. Same way, electric refrigerator rated 400 watt operate 8 hours per day. What is the cost of the energy of operated 8 for the 30 day? Okay, so here first we have find 400 into total energy, okay, which we know it as a 400, okay, which we have given what? Okay, and the time is 8 hours per day. So 8 into 30, okay, because we have given up to how much? Okay, 30 days. Okay, so it will be 96000. We have converted into kilowatt per hour. Okay, so kilowatt per hour is multiplied with the rupees 3 per kilowatt. Okay, so it will be 288 meter.
We can light up a 2.5 volt torch bulb using a 1.5 volt electric cell in an experiment. We simply have to connect the positive terminal of the cell with any one of the terminals of the bulb, and finally complete the circuit by connecting the negative terminal of the cell to the second terminal of the bulb. The bulb then glows. The word circuit is very important here. In this context, it will be electric circuit. In simple words, it is the path along which an electric current can flow. You can see here that a closed loop is formed. All the terminals of the electric cell and the bulb are occupied. So here the electric current is flowing along a closed path. We say that electric circuit is complete. But how exactly does electricity flow through the circuit? Well, it is difficult to explain how exactly it flows. However, I will try to give you an intuitive explanation of this phenomenon. You will learn more details in your higher grades. Basically, it's said that electricity or electric current is a flow of electrons in one direction.